Hi, I'm Deborah Kurata. I'm a software developer and Pluralsight author coming to you from sunny California. Let's get started. 4 wicked RxJS pipelines, eh? Nice hat. All right. So what are we going to talk about? RxJS pipelines. Retrieve related data, lookup reference property, grouping pipeline, and autocomplete pipeline. Frequently I'm asked, how do you even start to think about all of this RxJS stuff? And my tip is to think of it this way. What do you have? What do you want? And when do you want it? So let's dive into our first pipeline and give those questions a try. So retrieve related data pipeline. So in our example here, we have a data entry box and we're going to be typing in a user. Now you could kind of imagine that to be a login with the username and password, but we're entering a user, which is a username, and we're showing all of the posts for that user. So what do we have? Well, we have the typed in username. What do we want? Well, we want the list of posts. Our problem is, though, that our post has a user ID and we have the user name. So how do we deal with that? We're going to first have to get the user so that we can look up the username, get the ID, and then look up the post for that user ID. So we are retrieving the related data for the user. When do we want it? Well, we want it anytime the user changes. So every time that action occurs where the user types in a new username, we want to actually have that action cause this set of posts to show up on the UI. So how do we do that? Whenever you hear action or think action, some action is going to occur and then it's going to cause our RxJS stream to do something. We should always be thinking about a subject or behavior subject. So our tip here is to respond to any action using a subject or behavior subject. So here's an example. Okay, we had that user name that the user is typing in. So we're going to define a subject for that, and we're going to make it a new subject. And a subject is just a special kind of observable that we can create ourselves. Often we are just given our observables, for example, our HTTP GET, but we want to, in this case, create our own observable. So we're going to create our user subject, and we're making it private so that no other code in the application can emit anything into that stream or complete the stream or error out the stream. Our user name is going to be a string, so we specify string as the generic parameter here. Then we create a second property and we suffix it with $, indicating that it's an observable. And this is our read-only version of our subject, which is the observable part. And we don't make that one private because we want any code in the application to be able to access that and get the emitted items from that stream. Alternatively, we could use behavior subject. The primary difference between subject and behavior subject is that behavior subject has a default value. So when one of the components subscribe to our entered user $, they will get that default value. If they subscribe late after the subject has emitted several things, it will always give them the last emitted item. Whereas if you subscribe to a subject, you'll always get the next emitted item. So in our case, we don't really want a default user, so we're going to use a subject. And then here's our retrieve related data pipeline. So we start with our subject, our this.enteredUser$, the observable part of our subject, and we're going to pipe it through our pipeline. So the first thing we're going to do is use a switch map on the username emitted from entered user $, and we're going to use that to issue an HTTP GET request. Here we're using regular expressions. The backend that I'm using here in particular, the API, is allowing queries using regular expressions. So here's my hat and my dollar, because I want to ensure that I'm matching the username exactly and not as a part of another username that might match it. And because this query has no idea that I'm only supposed to have one username or user record that matches that username, it is going to return an array of users. So the next thing then we want to do is take that users, and we're going to pull off the first user, because we're assuming that our username would only match one user, and that's the user's ID that we want. And we use that to get our posts. All right, so a couple of questions that might come up when looking at this code. First of all, what about exception handling? As soon as we add that in, it's going to make our pipeline a little more complicated looking. The other question is, what if our username isn't found? This user 0 is just going to crash big time. It's going to throw an exception. So how do we deal with that? That brings us to our next tip: refactor code into manageable and reusable pieces. Frequently, when we see RxJS pipelines, they're big, long things. And when you're doing a presentation, that often is a whole lot easier to see the code in one big chunk. But when you are doing a real application, you want to break it up into manageable pieces. So what are we going to do for our particular example? Well, we're going to write a getUserID method that takes in a username, and it uses that exact same HTTP GET. And here we have our error handling, and here we have our check for a user's length of 0. So if we don't get any users back in that array, we're going to assign an ID of 0, assuming a user ID of 0 is not a valid user ID. Otherwise, we will get the ID off from the first user. We could even add code here to check if there is more than one match. And if so, do some other kind of logging or generating some kind of error. The other nice thing about doing it like this is we could actually put this in a user service. So our post service doesn't get so filled up with all sorts of unpost related things, like getting a user ID from a username. Then we can write another one that gets posts for user. So given the user ID, it knows how to get all of the posts for that user. And here again, we have our exception handling. We could actually add code in here before our return that checks that user ID. And if the user ID is 0, it returns an empty array instead of issuing the HTTP request. So it gives us a place to provide more code. Now, pushing this code down a minute, our pipeline then ends up looking like this. So we are reacting to every time the user enters something. It's going to take that username and emit it. And then our switch map takes that emitted username and it gets the user ID. Then the next switch map takes that user ID and gets the post for the user. The other interesting thing about these pipelines is it takes the emitted value. So here we have the user that is being emitted into the user stream. It's going to use it in this next operation. So this switch map emits the user ID, which is then used in the next switch map. So you don't have to write code to tell it to somehow wait until one is done or have nested subscribes. This will automatically wait for the emission from the prior one before it executes the next one. Okay, so that's our retrieve related data pipeline. If you look at this, though, there's a little bit of an issue. Here we've got this category with a number, a category ID number. And I don't know about you, but most users I know wouldn't remember what a category 9 versus a category 1 was. They would much rather see it more like this, where we've got a name. So this brings us to our next pipeline, a lookup reference property pipeline. And here our idea is that we want to take our category ID and we want to look up that reference property to get the category name. So going back to our questions, what do we have? Well, we have our post, and presumably we could get our post categories. And so we have those two. What is it that we want? We want to add a category name down here as part of our posts. Then we want to be able to take our category ID, look it up in the post category, And then we want to take the name and put it into our category name down here. When do we want to do that? Whenever we get this data. So we have two things. We've got this post category and we've got this post. So we've got two different streams here. How are we going to work with those two streams? Well, whenever you want to work with multiple streams, our tip here is to use a combination operator. So here's our combination operator, posts with category. So it's going to have that category ID replaced with the category name. And our combination operator is combine latest. So we're going to get all of our posts, we're going to get our post categories, and combine latest is smart enough where it won't emit until both of these streams have emitted at least once. So it will not continue until it has both the posts and the post categories. But again, this might bring up some questions. What about exception handling? Again, we have no exception handling here. And how do we reuse the retrieved categories? Now, posts might change on a moment's notice. You might have all sorts of new posts being generated, but your post categories may not change or very, very seldom change. So why do we get them every time we need them? Why don't we get them once and cache them? So how do we do that with this code? Well, that goes back to our prior tip. What we want to do is break it into little pieces. So we're going to define an all posts stream, which gets all of our posts. And again, it has our error handling here. And then we're also going to have an all categories, and that's going to get all the categories. And since we're breaking this out into bits, we can also put this code where it belongs. This all categories would belong in a post categories service instead of in our post service, again, breaking up the responsibilities. It has a catch error to handle the errors, and it also has a share replay of 1. And what that will do is basically cache the last emitted item. And it's an HTTP GET, so it only emits once. So it's going to cache that set of categories for us. So the next time our code references all categories, it's going to get that cached list and it won't keep hitting our server. All right, so our combine latest then looks like this. It's going to take this all posts, which already has the error handling, and our all categories, which is in our category service, which is going to be cached. So anytime we get the posts again, it will not have to get those categories again. But what about the rest of our pipeline? Well, this is what the rest of the pipeline looks like. A combine latest returns an array where the first element is the emitted value from the first observable that you pass in here. And the second element of the array is the emitted item from the second observable here. So we're using array destructuring to give each of those elements a name to make them easier to work with. Then we're using a simple array map because now this has emitted the posts for us. So we're just using that array and calling map so that we can loop through each post. For each post in that array, we are creating a new post object. So here's our strong typing, our new post object. What we are doing is we're using the spread operator to spread our existing post properties and their values. And then we're adding this category, and we're using the find method on this category array to find the matching ID and then get its name. All right, so what we end up with then is an observable that emits a post array. We again might have some questions here, like what if this ID isn't found? Well, we could put an or on here, the two straight lines, and we could do or and some other string name like not found or unknown category or general or whatever we'd want to use if the ID isn't found. What if there are multiple lookups? Well, if we had yet another thing we wanted to look up, maybe we want to take that user ID and display it as a user name, which would be a lot friendlier. We could just add another stream up here. We could add then another array element. And then down here, when we're creating our new post, we would add whatever other properties that we need. And lastly, how do we reuse this logic? Well, we might want to match up these categories when we're getting all posts for a user and not just all posts, or all posts within a specific amount of time or whatever. So we might want to be able to reuse this logic. So again, we're going to go back to the prior tip and we're going to create a method to do our mapping for us. And then our pipeline just calls that method in order to handle that mapping. All right, and then that gives us our categories. Going to our next pipeline, this is a grouping pipeline. So here we want to group the posts by category. So this is going to be all posts grouped by category. So how do we do a grouping? Again, we start with what do we have? Well, we have the posts. What do we want? We want the posts grouped by category. When do we want it? We want it whenever we get the data for this page. So how do we go about doing that? Well, luckily there is a group by operator. So here is our posts grouped by category. And we're going to start with our posts with categories. So again, we're able to reuse this stream because we've defined it as a separately accessible stream. So we can reuse that and we can pipe it through. So what is the purpose of each of these items in our pipeline here? Well, group by expects to get one thing and then another thing and then another thing and then another thing. But what does posts with category emit? It emits an array. And if we just gave that array to group by would go, okay, I just have one thing. What am I supposed to group it with? And it wouldn't know what to do. So the first thing that we're doing is a concat all, which is going to cause each array element, each of our posts, to be emitted. So our group by gets each post from the concat all. Then the group by takes a key selector, what we want to group by, which is our category ID, and then an element selector, which is what we actually want to be grouping, and that is our post. The group by then gives us a groupable observable. And so what the merge map does is the merge map turns that into a tuple. So what that does is it takes then, it uses zip, and for each group, it emits one tuple with the ID, our group key, which is our category ID. And then it takes all of the posts that match that, and it does a to array on them to put them into an array. So we end up with a tuple where the first element is our category ID and the second element is our array of posts that match that category ID. And then this wants to emit one group at a time. But our UI doesn't want one group at a time and then it disappears when the next one's emitted. It wants an array of all of them. So we use to array on the end. And if you weren't able to quite picture that, this would be what it would look like. So we have category 5 has one array element, category 9 has two array elements. And if we dive into what each of these look like, array element 0 is our category 8, array element 1 is another array with our two posts in here. And then we can use, in our template, we can loop through these. So we're going to go through each group in our groups. Our post then is in the second element, which is 0 base, so it's 1, and that's how we display our UI. And that leaves us with this. All right. Our last and final pipeline is autocomplete. So here we're going to be typing something. So as we type an S, it's going to filter the list so it matches what we typed in order to help us autocomplete something that we're typing in. So what do we have? Well, we have our list of categories here that we're dropping down in our list. And we have seen already the code that we're using to collect those. What do we want and when do we want it? Well, this is a little bit more complicated. So we're going to do that on a separate slide. So first of all, when the user types, we want it to filter the list, right? I mean, that's the whole point. But we also want this to do some other things. We want it to be able to open if we click on it. So if the user comes to the page and clicks on this select a category field, it should open that list. If the user tabs into it or some other way provides focus into it, we also want to open the list. And lastly, if they click this little X, we want to clear whatever category or whatever part of category they had typed in and open the list. So we're doing 4 different things. We have 4 actions. Does that mean we need 4 subjects or behavior subjects? In a lot of cases, yes. For each action, we're going to want a subject or behavior subject. Okay, so what does that look like? Well, first of all, we're going to define our subject. So we only have 3 here: focus, click, and clear. The text one is going to be given to us, and we'll talk about that in just a second. So here is our input box and our button. So here is the text box that says it's for our selected category. And here we have the focus event emitting the item into our focus subject. And same thing for the click. It will emit into that as the user clicks on it. If you don't want, a lot of developers don't like to have a lot of logic in their template. And if so, you can do it like this one is down here, where it calls a method to instead do that. So on click, it's going to call the onClear method, and the onClear method clears the field and then emits something into the subject. In this example, I am using Bootstraps, ng Bootstraps type ahead, and they bind ng type ahead to search. And so they're expecting this to bind to a search function. And that's what we're going to see here next. So here's our search function. Now the search function gives us the text as an observable of string. And that's why we didn't have to create a subject for it, because it's going to give that to us. And instead of creating some massive, ugly pipeline that's going to handle all of this, we're going to break this once again into small pieces. So we're going to have debounce text is this text that we're getting. We're going to pipe it through debounce time. And that way, if the user is typing something quickly, it won't try to go out to get it after each typed character. It'll wait till they've stopped typing for 0.2 seconds before it attempts to do its thing here. We also have distinct until changed. So if the user types SAT, deletes the T, adds the T, deletes the T, adds the T, it won't keep trying to go get it until it actually is something else. All right, then click to open. We're going to pipe that through a filter. So if it's already open, it won't tell it to close. So we're only going to open it if it's not already open. Then we do a merge, and we take our debounce text, which is this guy, our click to open, which is this guy, our focus and clear, which come from up here, and we're going to merge them all into this operation stream. Then we're going to combine the operation stream with our categories so that we can work with both of those together. Now, again, the combine latest, as I mentioned before, that will only emit once both of these have emitted. Now, if we put all 4 of these and used combine latest on all of them, what would happen is the combine latest won't emit until all of the streams have emitted. That would mean the user would have to type in text, click, focus, and clear it before it would go ahead and do its filter thing. So by merging them first, the merge is sort of an or. If any of these things happen, it's going to emit something. And then what we're going to do is we're going to look for an empty text. And if that text is empty, then we display all the categories, otherwise we filter. And we're using a regular expression here. We're only using the hat because we want it to just do a starts with. And this I here is a case insensitive check. So we're using regex and testing for that value. And that then gives us our autocomplete pipeline. All right, so for wicked RxJS pipelines, thank you so much. I hope you enjoyed this talk and that it will help you do your own pipelines and your own projects. Thank you very much.